Hey all, welcome to another session with me, Varun, on TechTablet. And in this session, we will now continue the next part of machine learning algorithm, that is decision tree. In the previous videos, we've already covered a couple of topics, and I hope you all know we've covered topics like what is data science, uh, what is linear regression, what is logistic regression. Now we are coming to what is decision trees. In the videos to go, we would be covering what is random forest, KNN, SVM, K-means, and then we will also head to the coding part of it. That's the plan. So now, talking about this video in specific, we would be talking, or we would be understanding decision tree. And for all those of you who have queries or would want to communicate with me directly, you can follow me on my Instagram account, which is Hyderabad Chora, and there's the same ID, or even there's the same name with which you can also check out my YouTube channel, on which I have my rap videos uploaded. Right, I also do rap as a part of my passion, and this here is my Facebook ID. Now, going forward and understanding the agenda of this session, the agenda would be to understand what is a decision tree, important terminologies associated with it, advantages, disadvantages, and how would you build one? Like, what are the different steps associated that you might have to come across if you are looking forward to build a decision tree? So now let's go forward and understand. And to give you a small introduction about myself, well, guys, I started working with SAP ABAP, moved on to SAP UI5, then started this YouTube channel with this TechTablet, started becoming a corporate trainer and freelance trainer. Currently working as a data scientist and a data science trainer, and probably a struggling artist is what I would want to call. And I work on these three languages, that is R, Python, and TensorFlow. And yeah, this is my area of expertise. Now going forward and understanding what is decision tree, let us go ahead with that and not waste time any further. So now what is a decision tree? So as you're able to see, guys, it is a support tool. Okay, another language, it's a machine learning algorithm. We'll keep it simple, all right, that uses a tree-like graph or model of decision. So here you can see it's in a tree format. Is it not? So here, based on one decision, you would be having two, and this is again split into two. So this is a complete tree-like pattern that is going from one to another. So this is what we call a decision tree. Now here, when we talk about it, it is one way of displaying algorithm in a controlled manner. And this is a supervised machine learning algorithm. Please do not forget that it's a supervised algorithm. Supervised machine learning algorithm is exactly what is written here. And when you talk about decision tree, okay, the problem, so that all options can be, okay, it allows us to analyze fully the possible consequences of a decision. So here you can see what if it is greater than 9.5, if it is less than 9.5, if it is greater than 2.5. It's pretty easy to understand. And this becomes also one of the biggest advantage of decision, which we will be talking about in probably 1 or 2 minutes, right? So now I hope you have understood what a decision tree is basically. Okay, now going forward, how does a decision tree get split? Well, guys, there are actually many factors talking about it technically. You have things like information gain, you have things like entropy, and you have a lot of other things which are calculated when a split, or when there is one information that's passed on from one to another. But still talking about how do you split a decision tree, theoretically it goes from root node to the leaves. Okay, now if this is the root node, then it keeps going further and further and further based on the conditions that you created, and all these are branches and these are the leaves. Now this is the final leaf or the end terminal or the terminal leaf. There are many ways to address this, all right, and this part becomes your root. All right, this is your end or your terminal, the way you want to call it. All right, so now going forward here, decision trees, they build classification or regression models. Guys, please do not forget, even decision trees can be used for classification or regression as well. And it breaks down the data set into smaller and smaller subsets. That's exactly what I'm trying to explain here, while at the same time an associated decision tree is incrementally developed, which means that the associated trees are developed in the process of breaking down the data. And a decision node has two or more branches, and a leaf node represents the classification or a decision. And that's exactly what you were talking about, the end or the terminal or the leaf, the terminal leaf. There are many ways to address this. Now, the important terminologies here are root node. We've already seen what it is. It is the starting point of your data or of your algorithm. Then splitting, it talks about how your data is getting split. Okay. Then you have your decision node, you have your leaf, which is your end. Pruning, which is a process, guys. Pruning is not a part. Pruning is a process of removing data, unnecessary data. All right. There are two types. You have pre-pruning method and you have post-pruning method. We will talk about this in detail when we move on to the technical part of it. You have branch. You've seen all these are branches here. This is a branch. I mean, the ones which are connecting to a leaf is what is called a branch. And then you have the root node or the parent node. So these are the important terminologies that you have associated with decision tree. Going forward, there are different types of decision trees. The first one is categorical, and the second one is continuous. Categorical basically means a yes, no, or a maybe types. Now, guys, unlike logistic regression, you need not have only 0, 1. You can have 0, 1, 2, 3, or any number of factors. And then talking about uh, the second type of decision tree, which is continuous. Here you would be having numbers. All right. The example which we saw in our first slide. Okay, let me just scroll you to the first slide. This example which you see here is a typical example of a continuous variable. If you can see, it's all the classification or the split is based on numbers. All right. So now going forward again, so you have two types. One is the continuous variable, and the other one is the categorical variable. And here we have an example that's given. The problem is to predict whether the customer will pay his renewal premium or not. Well, I have a buy or I have a two-way, kind of a split here. So here we know that the income of customer is significant variable, but insurance company has no details. Now, as we know that it's a very important variable, we can build this using decision trees to predict basically if your customer will pay the payment or if he would not. So we are trying to find out if he's a defaulter or if he's not. All right, so things like these can definitely be worked upon using decision tree. Now, what are the steps that you should follow when you're working on a decision tree? As we all know, the first step, first things first, you would be importing a data set, you would be importing the libraries, then you would be, creating a train test split or, something like that. Then you would be building a model. Then you would be making a predictions. Now, here, when you build a model, you would be implementing the decision tree algorithm, and here you would be splitting your train and test. Now, we all know that test is generally between anywhere between 25 to 30%, and train is anywhere between 65 to 70%, because training should always have, your training model should always have greater data. And then you would make predictions, after which you would measure the performance. Now, performance measurement is done in different ways. You have accuracy test, we have seen, you have case chart, you have case value, case statistics. So you have different means to find out the performance measured, to measure the performance. Okay, then you have after which, if you see that your accuracy is low, or probably if the value that you're expecting is low than what it should be, then you would move on into hyper parameter tuning, and then you repeat the steps again. But now when you repeat, you would be repeating it again from step 5. You will not be going back to cleaning the data set and all. So this is how you work on a decision tree. Now the advantages are, it's very easy to understand. Probably I would say it is the most easiest to understand across all machine learning algorithms. It's useful in data exploration, yes, and less data cleaning is required. That is something that's understood, because it can handle all kinds of data, and it can handle all kinds of information. It becomes very easy to handle or to work on decision tree. But unlike Every algorithm decision tree also does not walk out without any disadvantages. So let's talk about the disadvantages now. Now here you can see that a small change in the data, guys, very important point, a small change in data can cause large change in the structure of decision caused by instability. So let us assume a small thing here. You have values that is less than zero point 0.5. So here, if I have values, with anything which is made or anything which is malignant or benign, and if I have a value of zero point 0.5, then where should it go? Would it go here or would it go here? So now, I mean, you might say it's less than or equal to zero point 0.5, but this is just an example for you to understand how it can get complex. All right. Now the second one is for a decision tree calculation. Sometimes calculation can go far more complex. Yes, I would definitely not want to argue against this point. The third one is decision tree often involves higher time to train the model. Yes, the training time is higher, which is in actual a disadvantage that you might want to consider when you're working on this. Decision trees training is relatively expensive as complexity and time taken is more. I think the second point and fourth point are somewhere down the line interrelated. Then the next one is decision tree algorithm is inadequate for applying regression and predicting continuous values. Guys, please understand this once again. It is inadequate for applying regression, which means that it is good when you are using it for a classification model, also for predicting continuous values. So these are the 5 disadvantages that you should remember, and probably if you are able to answer them in an interview, it should act as a game-changing environment or a game-changing answer for you. So these are some things that I wanted you to know in this session. In the upcoming video, we would also cover some other topics like random forest, naive Bayes, confusion matrix, KNN, K means there's a lot to go, guys. And if in case you like the video, then guys, please hit the subscribe button, because when you do that, you would be having access to a plethora of videos with the notification if you hit the bell icon as well. Also, do hit the like button, because that would encourage me to make further videos. And when you hit the share button, please do share this with your friends, because sharing is caring. And also, when you do this, if there's anyone who might gain some help from this, I think I would be the happiest. Thanks a lot for being there. This is me, Varun, signing off, wishing you and all the best for the interview or for the process that you're about to take up. Thank you for your patience, and thanks for being there.